Hi students, welcome. In the previous video, we learned about the embedded systems and the core of embedded systems. So in this video, we'll be learning about the main element of embedded system applications, that is memory. The processor or controller based embedded system needs memory as an important part of it. Some processors or controllers contains built-in memory, some needs external memory. The processor which needs built-in memory are called on-chip memory and which needs the external memory is called the off-chip memory. Also, to hold the temporary data during the working are also used. Hence, there are different types of memory used in embedded system applications. Program memory or code storage memory of an embedded system stores the program instruction. The diagram shows a classification of program memory, that is ROM. So there are different classification. They are flash, PROM, masked ROM, EEPROM, EEPROM, NVRAM. Program memory or the code memory is non-volatile. That means storage memory that the contents are retained even after the power to it is turned off. So let us see one by one the classification of the program memory. The first one is a masked ROM, MROM. MROM is one-time programmable device and programmed by the manufacturer itself. It used Huawei technology for storing data. It is low cost for high volume production. It is unable to modify the device software against the software upgrades. That is, MROM is permanent bit storage. It is not possible to alter the bit information. The second type of classification is programmable read-only memory, that is PROM, or one-time programmable memory, that is OTP. PROM or OTP is not pre-programmed by the manufacturer. The end user is responsible for programming these devices. A PROM is a memory chip on which you can store a program, but once the PROM has been used, you cannot wipe and use it to store something else. OTP is widely used in commercial production of embedded system. Next, moving on to the third classification, erasable programmable read-only memory, EEPROM. PROMs are not suitable for development purpose because during the development phase, the code is subjected to continuous change. EEPROM gives the flexibility to reprogram the same chip. EEPROM contains a quartz crystal window for erasing the stored information. An EEPROM is a special type of PROM that can be erased by exposing the window to the ultraviolet rays for some duration. And the advantage of this is it gives the flexibility to reprogram the same chip, and the limitation is it is tedious and time consuming process. The next classification is electrically erasable programmable read-only memory, EEPROM. An EEPROM is a special type of PROM that can be erased by exposed it to an electrical charge. The data present in this memory can be altered, erased and reprogrammed using electrical signals at the register or byte level. For system design, it provides greater flexibility. The capacity of EEPROM is limited when compared to the standard ROM. The advantage of this is it provides the greater flexibility for the system design. And the limitation is the capacity is limited when compared to that of the standard ROM. Next, moving on to the flash. In today's embedded world, the most popular ROM technology is a flash. It combines both EEPROM reprogrammability and high capacity of standard ROMs. Flash memory is organized as sector or pages. The erasing of memory can be done at sector level or page level without affecting the other sector or pages. Each sector or the page should be erased before reprogramming. The lifetime is not infinite. The erasable capacity of flash is 1000 cycles. Example, the flash chip SST39LF010 from the microchip. The next concept is the random access memory or read-write memory. So it is classified into three types: SRAM, DRAM and NVRAM. The RAM is a data memory or working memory of the controller or the processor in which it can read from it or write from it. RAM is volatile, that is, when the power is turned off, all the contents are destroyed. So let us see one by one the classification of this working memory. So that is SRAM, DRAM and NVRAM. The first one is the static RAM, that is SRAM. So in this type of RAM that holds data as a static form, that is, as long as the memory has power, it stores the data in the form of voltage and it is made up of flip-flops. Static RAM is the fastest form of RAM available. It is fast due to its resistive networking and switching capabilities. SRAM is realized using 6 transistors, that is MOSFETs. 4 of the transistors are used for building flip-flop part of the memory cell and other 2 for controlling the access. The simplest representation of an SRAM cell can be visualized as shown in the diagram. To make it simpler to understand, it can be visualized as 2 cross-coupled inverters with read or write control through the transistor. It is shown in the second diagram. So now, coming to the first diagram, that is SRAM cell implementation, the access to the memory cell is controlled by the word line, which controls the access transistors, that is MOSFETs Q5 and Q6. In order to write a value to memory cell, apply the desired value to the bit control lines. Let us understand how it is done, how it is used to read and write the data. For writing 1, B is made is equal to 1 and B slash is made is equal to 0. If we want to write that is 0, so the bit line B is equal to 0 and B slash bit line B slash is equal to 1, and we also make the word line high, that is equal to 1. This is for writing data 1 and 0. If you want to read the data, that is for reading the content of the memory cell, both bit line, that is B and B slash bit lines, that will be is equal to 1, and set the word line to 1. So SRAM are low capacity and high cost memory. So this is all about the static RAM. The next two types, that is dynamic RAM and NVRAM, will be discussed